Alright, so we're going to be looking at cofunction identities of trig this time. This is where we're trying to convert from like sine to cosine, tan to cotan, or secant to cosecant, something along those lines. So we've got sine x equals cosine of pi over 2 minus x, and we're going to prove this to be true. We're going to use 3 pi over 4 as our example. So from the origin, or not the origin, but from 0, we're going to go to 3 pi over 4, and we're going to see that the sine value is root 2 over 2. We're also going to go to pi over 2, that's our starting point, and we're going to go down 1, 2, 3 pi over 4, which is going to land us right down here. The cosine there is root 2 over 2. Is root 2 over 2 equal root 2 over 2? Yes. So we can see that this works out. Sine x does equal cosine pi over 2 minus x. Let's take a look at tan x equals cotan of pi over 2 minus x. Does this work out? Well, let's see what we got here. We're going to look at 11 pi over 6. So if we're, again, starting here, we're going to go all the way around to 11 pi over 6. So we almost made a full circle. And we see that the tangent there is negative 1/2 over root 3 over 2. Okay, that's in blue on the left side. The other one, we're going to start at pi over 2, right here. And we're going to, again, go all the way around the circle, but we're going to go to negative direction. So we're going around this way, right? And we wind up right here. To take a cotangent, we're going to go cosine over sine. So it's going to be negative 1/2 over root 3 over 2. So don't get confused about what I'm doing right here. I'm just doing a more elaborate version of copy.flop, or rather I'm doing the academic way of doing this. So when we do copy.flop, what we're actually doing is we're multiplying the bottom fraction by its inverse, right? So if we have negative root 3 over 2, we'd multiply by 2 over negative root 3, so that everything cancels out. When we do the bottom, we must also do the top. So if I took this bottom piece away, what you'll notice is that was just copy.flop, right? Flip to the top, put a dot, multiply. But this is what's actually going on if we actually think about this academically. So once we do that on both sides, we're going to find that it is negative 1 over root 3 equals negative 1 over root 3. And as I said in previous videos, normally we want to get that root 3 out of the denominator, but in these cases we're just trying to prove that they are equal. Once we have that, we can stop. But if we were doing anything with it, we'd want to continue. So with these, it turns out that this works with all the trig types. So we don't need to know different versions, right? Sine pi over 2 minus theta equals cosine theta is, that same setup works for all of them, whether we're going from sine to cosine or cosine to sine, whether we're going from tangent to cotangent or cotangent to tangent. And then lastly, whether we're going from cosecant to secant or secant to cosecant. We always use the same format here. So these are fairly easy to remember. I think we're good.